I'm actually really surprised that that thing's not password protected. I was able to just connect to it.
Hello and welcome back to Calculus2. This is going to be the part 2 of our chain rule talk, where we are going to discuss some of the spicier examples that you are going to run into as you move through your calculus, differential equations, and physics career in life. That includes all of the engineering and everything else you can come up with. I already mentioned that about 99% of your derivatives from this point on will be some form of a chain rule. And we have seen a lot of basic examples in the past. Let's just, warm up here with something like the derivative. Let's do in respect to time. How about that? Derivative in respect to time of, say, e to the t squared plus 2t minus 1. So what we said is we have the outer function, we have the inner function. So the f of t would be the outer function, which is e to the t, and then g of t would be the inner function, which is t squared plus 2t minus 1. And if I am to take the derivative of this, the derivative of e to the t would be e to the t, but I have g plugged in. So it's going to be e to the t squared plus 2t minus 1 times the derivative of the exponent, which is 2t plus 2. Derivative of negative 1 is just 0. So that was the basic chain rule idea we had. And now what we want to do is take a look at some of the problems that you might get. So let's consider the derivative of 3x squared plus 6x to the 4th power times e to the x squared. So what do we see in this particular problem?
Like which rule? Or
Yeah.
Power rule?
Product rule. We see a product rule. There is times in between the two, and this one is product rule, which is the derivative of the product is uv prime plus vu prime. And then when you start taking derivatives of each of the individual ones, like a u and a v, you will have chain rules for each. So you can write that this is chain rule within the product rule. So chain within the product. Chain within the product. So now we need to do the product rule and then use the chain rule every time when we have to take the derivative of each individual one. So the product rule goes like this. Copy the first one, which is 3x squared plus 6x to the 4th, times the derivative of the second. Well, that's the derivative of e to the x, so that's e to the x squared times 2x. And this is the chain which was the part of v prime. So this is copy u times v prime, but the derivative of v now had the chain inside. Plus copy the second, which is e to the x squared, times the derivative of the first. Well, the derivative of the first is going to be 4 times 3x squared plus 6x to the 3, right? So you can think of this whole thing over here as x to the 4th, right? If it's x to the 4th, then the derivative of x to the 4th is 4x cubed. And then you have to follow with the chain, which is derivative of the inside, which is 6x plus 6. So that would be the chain. So here is a chain, right? And now this is over here copy V, and this over here is U prime. There's a plus in between, right? So it is the product rule formula, and the chain rule appeared inside. Okay, so now we simplify this if possible. 2x, then 3x squared plus 6x to the fourth, e to the x squared, plus 24x plus 1 when I factor out 6, and then 6 times 4. And then I have this 3x squared plus 6x cubed, and then I have e to the x squared. Remember what I said? You have to factor if you can. So we can kick out 2, 3x squared plus 6x to the 3, e to the x squared. So all of that stuff is common. 24 is divisible by 2. Then you have the same parenthesis of 3x squared plus 6x. One has 3 of them, one has 4 of them, so 3 on a pile, and e to the x squared. So what's left? Well, from the first one, we have x times 3x squared plus 6x to the first power, because one of them stays, plus 12x plus 1. Because, right, 2 came out, all 3 of the quadratics and the e to the x squared all went out. And now simplify the parenthesis. So we have 2 times 3x squared plus 6x cubed e to the x squared. And now we have 3x cubed plus 6x squared plus 12x plus 12. And you can kick 3 out. So that's going to make it a 6. 3x squared plus 6x cubed e to the x squared. And over here, when I kick 3 out, I just get x cubed plus 2x squared plus, I'm taking 3 out, so that's 4x plus 4. And that's where the problem ends. Why are we simplifying? Because chapter 4 takes this answer, says a equal to 0, and then you set each one of the terms to 0 to find values that you will need for chapter 4. So practicing simplifying now is important for your future. So this problem was chain rule within the product rule. What is the derivative of ln of (3x squared e to the x minus 1)?